Hello, I'm audible now?
Yeah, now it's okay.
Oh,
Perfect.
okay. Okay, so let us start with the CCNP ENCOR introduction. Okay, so let us see that what we are going to cover during the upcoming weeks. Okay, so let me just start here. I hope everyone has done with the CCNA. Is there anyone who haven't done the CCNA? So you must do the CCNA first, okay, so that you can start with the CCNP ENCOR part. Okay, so basically we will start with the switching part here. In the ENCOR, we will start with the switching part. Then we are going to cover the routing part. Then there are some topics that will remain. That topics we are going to cover after that. Okay. Okay. So they will provide you CCNA course free of cost. Okay. So let me just tell you that how we are going to start with the switching. So first thing that we are going to start, we'll start with the basics of switching. We'll start with the basics of switching. Okay. Then we will learn about the CDP. Can anyone explain me what is CDP? Cisco Discovery Protocol. What is the use of Cisco Discovery Protocol?
Yeah, to discover other
It's
network
work only with the Cisco devices, I think.
Yes, yes. But what is the use of this protocol?
to discover the connected devices
Yes, to know
in the
about
network.
its neighbor devices, right?
Yeah.
Okay.
Network platforms.
Yes. Then we are going to start with the VLAN concept. Okay. I think most of you are aware about the VLAN. Why do we need VLAN? What is the full form of the VLAN?
For segmentation.
Yes, it's virtual LAN. Okay. Why do we need VLAN? Someone said segmentation.
For layer 2 segmentation.
Okay. For layer 2 segmentation. Any other word? Any other term?
Security, I think.
Security. Okay.
Subnetting.
Subnetting, we can say, but not properly here. Okay. Any other thing? Tell me related to the broadcast. Tell me related to the
We can
broadcast. Please mute your mic, guys. Who is this? Okay. Tell me related to the broadcasting. What it does to the broadcast network.
Segmenting the broadcast domain. The layer
Yes,
2
yes.
segmenting.
It segments the what? The broadcast network.
Domain.
Okay. Then you guys heard of trunking. Okay. In trunking, we have some encapsulation methods also. What are those?
.1q.
.1q and ISL. Okay. Mostly nowadays we only use what? .1q. Okay. Why? Because it supports what? Native VLAN. Okay. If you guys are not aware about some terms, don't worry. Okay. When we will start with these topics, we're gonna go step by step. Okay. Right now, I'm just giving you the overview. That what are the things that we are gonna cover in our CCNP ENCOR. Okay. Then the most important part of the switching. This is the most important part, which is the STP. Can anyone tell me what STP stands for?
Spanning tree protocol.
Spanning tree protocol. Why do we need spanning tree protocol?
To prevent layer 2 loops.
Yes, to prevent the layer 2 loops. What do we have for the layer 3? What do we have for the layer 3? Sorry?
As a device?
We have TTL. Yes. For the layer 2, we use what? Spanning tree protocol. Okay. In the spanning tree protocol, we will see the elections. Okay. We will focus on the election, how election works. Okay. Then we will see STP protection, how we can protect our network. Like we have loop guard, root guard, BPD guard, BPD filter. Okay. Some of things maybe you guys have heard of. Okay. Then here we have RSTP, MST. Okay. Multiple spanning tree protocol. Okay. When we will done with the STP. So basically this is the only topic that will take around 7 to 8 sessions. Okay, because it has too many in-depth knowledge in this STP. Okay, after covering this STP, what we are gonna do? We're gonna go with the ether channel. Why do we need ether channel? We have ether channel concepts on the CCNA also. They have defined it. What's the need of the ether channel? Can anyone tell me?
Improve the bandwidth.
Yes. How we gonna improve that? By binding the ports.
Binding. Okay.
Yes. Okay. Or there is one more term that we usually use. We call that as aggregate. Right? We call that as aggregate. Okay. So we have LSCP, PAGP are the protocols. Okay. After covering this ether channel, we're gonna go with the MLS. Okay, which is multi-layer switch. Okay. Then we have one more topic in the switch part, which is our high availability. Is there anyone who have done the firewalls? Anyone who is currently working on the firewalls? No one?
Like ISA Cisco firewall.
You are working on the Cisco firewall, ASA?
Yes.
Okay. So you have heard of HA? What is the meaning of the HA in the ASA? Basically, when one of our device goes down, then other device should work. Okay, it is a backup. So same concept we have here on the switch. Okay, for that we have three different types of methods, or we can say we have three different types of protocols. What are those? One is HSRP, second one is VRRP, and last one is GLBP. Okay, these two are what? These two are my Cisco proprietary. Okay, and this one is open standard. Got it? And after covering this, basically we have covered almost we can say 70 to 80% part of switch. Okay, the part that remain is we will cover the AAA concept. Okay, which will be authentication, authorization, and the accounting part. Yes, very good. Okay, after covering this, we will focus on the security part of which layer? Of the layer 2. Okay, so in the layer 2 switching, sorry, in the layer 2 security, what are the parts? What do you think? What are the topics we have in the layer 2 security?
ACLs.
ACL. Okay, VLAN ACL we can say, right?
Switch port.
Yes, VLAN ACL. Someone said
Switch port security.
Okay,
Port security.
We can say port based security, right?
Yes.
Port based security. And we have we can say DHCP snooping. Okay, basically DHCP snooping can come into the layer 3 also, but we will cover it here on the switch only. Okay, because here we don't have any like routing concepts here. Most of you guys are already aware about the DHCP. What is the use of the DHCP? Anyone? Can anyone tell me? Are you guys aware about the DORA process? Discover of or request acknowledgement? Okay, no problem. So after covering this DHCP snooping, okay, we are gonna do what? We are gonna do one more type of attack. That is my we can say dynamic ARP inspection. Dynamic ARP inspection, and one more thing, that is storm control. Okay, and we will do one more practical in which we use SPAN. Okay, please mute the mic. Okay, after that, what we are going to do? We're going to use the SPAN. Can anyone tell me why do we need SPAN? Anyone? Have you heard of SPAN?
Monitoring.
Yes, for the monitoring purpose. Suppose here, let me just clear everything. So suppose here, you guys have heard of IPS IDS, intrusion prevention system, intrusion detection system, right? Suppose I have my one firewall, suppose Palo Alto firewall. Okay, when this firewall is acting as intrusion prevention system, so it will do what? It will create policies to prevent the traffic in our network flow. Okay, when it is acting as what? IDS, that is intrusion detect system, it will only detect the systems, sorry, it will only detect the network. Okay, so that time my Palo Alto firewall will not there. Okay, like in my main network line, so it will suppose here right now it is acting as my, or it will only detect the system. Okay, so suppose this is my switch and here is my network. So what I'm going to do, I'm going to share this traffic that is going towards the internet. Suppose here is my ISP. Okay, suppose the traffic is going to from here to here towards ISP. So I want some packets to go here on my Palo Alto firewall so that it can do the monitoring part. Okay, so on this switch, what I will do, I will do a span. Okay, so what the span will do, it will capture whatever interface we will say that, suppose E0/1 to E0/10. These 10 interfaces should share that all the traffic that is coming on the particular interfaces should share on from this interface, suppose E0/11 interface. Okay, so all traffic will go here, and our this firewall will act as a monitoring device. Okay, don't worry, we are gonna do everything from the basics when we are gonna start. Okay, so we are gonna do the practical of each and everything. Okay, so these are the things, these are the topics that we are gonna cover on the switching part. Okay, after that we have the most important part, and we can say the most complex and difficult part, that is our routing. Okay, so in the routing you guys should focus on the what? Packet flow. Okay, we are gonna use the one capturing tool that we call as Wireshark. Okay, on this Wireshark we're gonna cover each and every packets. We're gonna see that how these packet flow works. Okay, after that, how we are gonna start the routing part? Basically I will just introduce you the routing, how many types of routing we have. Then we are gonna cover how static routing works, what is the packet flow in the static routing. Okay, and after that we have dynamic routing. What is static routing? Can anyone explain me? And what is dynamic routing? What is the difference between these two types of routing?
Static routing is in which you add a route to reach the destination manually in the device, and dynamic
Yes.
routing is by protocol. The protocol discovers automatically the other connected reachable networks, but you
Good.
need to configure this previously, and you need to set some parameters in this dynamic routing.
Yes, very good. So basically in this static routing, now there is one advantage of the static routing also. Okay, that here our device will use less CPU. Okay, CPU utilization will be less on the static routing. Okay, but here in the dynamic routing it will be more. Why? Because whatever routing protocol we are using, suppose if we will use EIGRP, or either we are going to use the OSPF, so they have all their messages. Okay, they will exchange the messages. So if they will exchange the messages, if they will run the algorithms, then our device CPU utilization will be high. So this is the main difference between our static routing and the dynamic routing. Okay, so when we are done with the packet flow, when we will understand that how static routing works, can anyone tell me how many methods we have for the static routing? Suppose these are my routers. This is the switch, this is the PC. This is the switch, and this one is the PC. How many types of methods I have for the static routing?
The
Can anyone tell
destination
me?
network, the network mask, and the
Two types, it's
interface.
interface or IP address.
Yes, exit interface and the
Next hop.
yes, next hop.
So,
Okay, so when we will do this part, when we will do this part, we are going to see that what is the error we face on the exit interface, and what is the, we can say, error we face on the next row. Okay, you guys have heard of proxy ARP concept, recursive lookup. Have you heard of recursive lookup? When router checks its routing table 2 times. Okay, no problem. Do you guys know what is ARP? Address resolution protocol. Why do we need ARP protocol?
Retrieve the MAC address of the
Yes, it resolute what? The full form
IP.
of the ARP
IP
is address
address.
resolute protocol. Okay, what it resolutes? It resolutes IP to MAC,
MAC.
right? Why do we need MAC? Because in the ARP cache, if I don't have the MAC information, then what it will do? It will not forward the packet. Okay, then a new packet will come. Suppose if I'm using what? In my layer 2, what we use on the layer 2?
Switch.
Ethernet, right? And Ethernet use which protocol? ARPA. And ARPA generates what? ARP packet. Okay, we are gonna see what are the information we have in the ARP packets. Okay, then only we're gonna understand what is the packet flow from here to here. Okay, if you understand this packet flow, okay, then you can easily understand the routing part. Okay, so I have, at the starting I have told you, at the routing, in the routing you have to understand what? The packet flow. If you understand it, you will able to do everything, any technology. Okay, every technology will be simple for you, because now you know how to learn the technologies. Okay, basically by understanding their packet flow, how a packet flows. Okay, from here to here. Okay, then after completing this, understanding that what are the static routing, what are this dynamic routing, then we are going to start with the proper protocol. My dynamic protocol. Okay, my proper protocol that I'm going to start with is my EIGRP. Can anyone explain me what is the full form of EIGRP? Anyone? It's enhanced
Inter gateway.
interior gateway routing protocol. Got it? Okay, it's then what? IGP protocol. Okay,
Distance vector protocol.
yes, we can say in the IGP it is what? Distance vector. We also say it advanced distance vector routing protocol. Okay, in some of the books, in some of the notes, you will find it advanced distance vector routing protocol. In some of the books, you will find it hybrid routing protocol. Okay, do you know what is multicast address of this EIGRP protocol? What is the multicast address of this routing protocol, EIGRP?
.10.
Yes, it's 224.0.0.10. What is the role of this multicast address? We have three things: unicast, multicast, and broadcast. Can anyone explain me the difference between all these three things? In the unicast, we have what? Single destination, right? In the destination MAC, we have the information of a proper well-defined. Suppose I have to go from A to B. Okay, what's that? It's unicast. Suppose I have to go into a particular groups. Suppose A, B, C belong to group 3. Okay, and here is my D. So where D wants to go? D wants to go in the 3 group. So it will be for the group. Okay, and here suppose I have A, B, C, D, E. Where this G wants to go? G wants to go everywhere. So that is my broadcast. Okay, why I am telling you this multicast like this in all 3 manners? So basically, whichever interfaces, suppose these are my interfaces, whichever interfaces will join this EIGRP multicast group, only that group will do what? Only that group will advertise the hello messages and accept the hello messages. Okay, what is the use of this hello messages in the routing protocols, dynamic routing protocols?
Neighbor
Why do we,
establishment.
sorry?
Neighbor establishment.
Yes,
Distances.
we have, yes, there are two reasons. One is my neighborship establishment and second one is keep alive, right? Keep alive. What do you understand by keep alive? That yes, I am alive. Okay, I am up. Now there are some other things that we are going to see: the FD, visible distance, and reported distance. We are going to cover each and everything. Okay, basically we will focus on what? EIGRP packets. EIGRP packets. What is the first packet? That is my hello. Can anyone tell me what is the second packet of the EIGRP? Basically, theoretical part we guys cover on the on the CCNA, right? If you don't know, no problem. After hello, which packet comes? Update. Very good. Update. Okay. Then we have query. Then we have reply and acknowledgement. Okay. Who's this? Okay, no problem. So after covering this, na, when
Which was the last one?
this is acknowledgement.
Okay.
Okay, ACK. In short, I write ACK. Not I. Everyone writes what? ACK. Okay. There is one. Basically, here I have. Suppose if you guys have heard of. What do you understand by next hop self? Please mute your mic if you're disturbed. Can anyone tell me what do you understand by next hop self? What is next hop self? Stuck in active state. Why I am asking you these things, na? Because these are the things that interviewer asks in questions. Okay, when he is asking you in EIGRP in depth. Okay, so you have to focus on these things also. Okay, when we will cover these topics. Okay, okay. Can anyone tell me just simple topology tables we have in the EIGRP? What are the kinds of tables we have in the EIGRP?
The adjacency
Look,
table.
it doesn't matter if you say wrong. Okay.
Adjacency table.
Sorry, which table?
Adjacencies table.
Adjacencies tables. Okay, we call that as what?
Neighbor
table. Okay. Any other?
Routing table. Topology.
Routing table. And last one is our topology table. Got it? So what's the difference between all these three tables? Why do we have three tables? Okay, let me just tell you in short form that in short way, sorry. So in the neighbor table, it will only have the information of its neighbors. Okay, not this router. Yes, we say point-to-point connected networks. Okay, in the topology table, it will have all the routes information, whatever we have in our network. In the routing table, it will have only the best possible routes. What? Best possible routes. Okay. So I was just asking you one question. I just here mentioned one word. What is the difference between neighbor and peer? Can anyone tell me? What is the difference between neighbor and the peer?
Neighbors are directly connected. Peers,
yes,
they are
neighbors are directly connected, and peers
use the same protocols.
Okay, peers are not directly connected. Suppose here, if you guys have heard of, okay, I will explain here on the. Okay, let us understand GRE. Okay, GRE, IPsec, these are also part of our CCNP ENCOR. Okay, little bit we have. So here, suppose this is my site 1, this is my ISP, and this is my site 2. For site 1, what is the peer of For site 1, who is the peer? This is site 2's this interface. Suppose this interface is 10.2. This interface is 20.1. Okay. This interface will become, so for site 1, who will be the peer? This site 2. Okay. Why I am not using neighbor? Because they are not directly connected. They are not directly connected. When they are directly connected, we call that as neighbor. Okay. Although we also call it as point to point. And if they are not directly connected, okay, then we call that as peer. Okay. Basically, it happens on the VPNs. If you guys have done the command for the IPsec, sorry, ISACAMP, there you mentioned what? Peer information. In that peer information, what you will see, what you will write? You will not write this, you will write this thing. Okay. If you guys don't know what is VPN, no worries. I'm going to explain you everything. Okay. Then we have some other types of routing filtering methods, offset list, distribution list, all those things that we are going to cover. Okay. Like the same way, we are going to cover what? Our another protocol. That is my OSPF. Can anyone explain me what is OSPF? What is the full form of the OSPF? It's a protocol that in most of the interviews, they're going to ask this
Link
OSPF.
state. Link state protocol.
Okay, it's a link state protocol. What is the full form of the OSPF?
Open shortest path first.
Yes, open shortest path first.
Based on the Dijkstra algorithm.
Yes, it uses Dijkstra algorithm. Okay, we also call it as SPF. Okay, what is the protocol number of this thing? Sorry, not protocol. What is the multicast address of this thing?
.6 and .5.
Yes, .5 and 224.0.0.5 and 0.6. Okay, for all the routers we use what? 0.5, and for the DR routers we use what? 0.6. Okay, what are the DR routers? Leave it for right now. Okay, and can you guys explain me the protocol number of this OSPF? What is the protocol number of OSPF? You can guess also. It's 89. Okay, guys, you have to remember two things. Okay, you have to remember protocol numbers and the multicast address. Okay, in the interview they will ask you, okay, these things. Now we have three, we can say 5 types of messages. Okay, we have hello, we have DBD, that is my database descriptions. Okay, so basically in every routing protocols now you have to focus on what? You have to focus on the messages, types of messages. If you will understand how messages works, then you're going to understand how a packet flow works. Okay, if you know how a packet flow works, then you can give the answer of the scenario based questions. Okay, because your concepts will get cleared when you understand what? The packet flow concepts. Okay, after DBD we have LSR. We call that as link state request.
Update.
Then we have LSU, link state update. Then we have acknowledgement. Got it? Have you guys seen the header of this OSPF? Can you tell me what are the information can you expect the OSPF header should have? It should have version. Which version we are using? It will have the packet length. It will have the type of package. It will have what? Router ID. What do you understand by router ID?
The OSPF ID.
Yes, what is the use of the router ID? What is router ID? Look, in OSPF router
It's
ID is
it's an identifier to identify the
yes.
instance in
We
the
can say
routing
it,
protocol.
yes,
It's locally configured. It's not applied on the global configuration. It's locally. It's a symbology.
Yes. How this router ID is selected?
Um,
This router ID, suppose I have the loopbacks in my this device. Okay, highest loopback will become what? Router ID. Okay, although we can
Manually
make,
or
yes, we can do it manually also. Okay, but how it automatically elects? By highest loopback. If we don't have the highest loopback, then highest interface IP address will become what? Our router ID. Okay, then we have one more concept, that is area ID. Why do we need area in OSPF?
or scalability for multi-zone
Yes,
machine.
very good. Best term, scalability. Okay, forward for the scalability. Then we have checksum. Then we have authentication type. Why do we need authentication on the protocols? Why do I need authentications on the protocol? Do you guys know, na, in the hello messages, there is one parameter that is known as authentication. If you don't know, no worries. When we will capture the Wireshark, there I'm going to show you what are the parameters we have on the hello. Okay. Basically, this authentication part is not compulsory. Okay. But why do we need authentication? Suppose here I have like this. Suppose here I have firewall. Okay. Look, let me make it one more time. Let me make one switch here. Okay. Suppose they have made the neighborship with each other. How they will start making the neighborship? By exchanging the hello packets, right? This router 1, this is router 2, and this is my firewall. Okay. So in this firewall, I have run what? I have run the OSPF. On the router 1, I have run the OSPF, and on the router 2, also I have run what? OSPF. Okay. When they will exchange what? The hello message, then they will form what? Neighborship, and they will exchange their routes. Okay. They will exchange their prefixes information. Suppose one device will come here. Okay. That's an attacker. He has to do what? He has to just know. Suppose any Linux tool, with the help of any Linux tool, he got the information of this network, that here I'm running what? 10.0.0 network. So he will do what? It will just write router OSPF and advertise that network. Then what will happen? He will join that network now. So he will get what? All the possible routes. And if this device will get all the possible routes in its routing table, then the packets will come towards this attacker also. So that's why we use authentication here on our routing protocols. Okay. So whenever our hello messages are exchanging, suppose on the R1 I have write down the password as 356, and here also 356, and here also 356. When they will exchange the hello messages, na, this device will also exchange the hello message. Okay. But what will happen? This authentication parameter will not match with this attacker, because this attacker doesn't know what this this password, the authentication that we have created on our dynamic routing protocol. Got it? After covering this these parts, we're gonna start with the neighborship states. These are also the important part we have in the OSPF. Okay. What are the neighborship states? We have down state or
Wasted.
attempt. Yes, init. We have two-way, extract, exchange. Very good. Exchange. Then we have loading, and then last one is our, we say it full state, or sometimes we say it full loading. Whenever you have seen when you have formed the neighborship between two devices, okay, then it shows one message, loading to full loading is done, right? If you have seen that thing. Okay. And the most important topic we have on the OSPF, okay, that is our LSAs. Okay. So basically here we are going to cover 7 types of LSAs. Okay. What are the types of LSAs we have? What is type 1 LSA?
Router, Type
Yes.
1 router.
Just tell me 3 types of LSA right now. Because in the CCNA, we have 3 types of LSAs. First one is my what? Router,
Route.
LSA. Next one is my
Network.
network, LSA. Okay.
Summary.
And the last one that you guys are familiar about is my summary LSA. Okay. Here we are going to cover the type LSA around type 7 till type 7. Okay. Basically, we have LSA till type 11. Okay. But we are going to cover how many types of LSAs? LSA 7. Okay. If you guys will show interest, then maybe we can do some extra LSAs also. Okay. Then there are area concept also on the OSPF. Okay. That part also we are going to do. And last one is same thing, our route filtering. How we can filter our routes. Okay. Can you even tell me that why do we need route filterings? Does anyone know what is the meaning of this route filtering? We filter what? Routes. Why we are filtering the routes? So that our routing, or we can say DVD table information, should be less. Okay. If you guys, okay, no worries, leave it for right now. Okay. Then the last protocol we have is what? The BGP. Okay. So in BGP, guys, you have to focus. If you are good with, if you have done practicals well in the EIGRP and the OSPF, okay, then you can easily understand what? Your BGP. Okay. In the BGP, you have to focus on what? Basically on the packets. Okay. On the attributes. Okay. That part we are not discussing anything right now. Okay. Because we have to focus on the EIGRP and OSPF. When we are done with these protocols, then we can understand BGP. Okay. If you guys have done the mastery on the BGP, then you will be called as a like high level kind of enterprise network engineer kind of thing. Okay. If you are very good at with the BGP protocol. Okay. Obviously, in the interview, now in the if you are giving the interviews, okay, suppose at the senior L2 level or the L3 level, okay, they're gonna ask you like this. You have to give the BGP interview, okay, and any other protocol of your choice. Either you can give the interview on the EIGRP or you can give the interview on the OSPF. Okay, they leave it on to you. Okay, don't think like that they're gonna ask you the messages on the OSPF, they're gonna ask you messages on the EIGRP. If they are giving you the options, then they are gonna ask you everything on in depth. Okay. Then in the ENCOR part, we still left with some concepts like we'll discuss about 2-tier, 3-tier design. Okay. Some basic parts. Okay. We're gonna see on premises, cloud premises. Okay. We're gonna see the redundant designs. Okay. We haven't talked about the net. We're gonna cover the net concepts. Okay. We're gonna cover the ACL concepts. Okay. We're gonna see the VLAN deployment, that is my wireless LAN network deployment. Okay. Then I'm gonna also introduce the SD-WAN. Okay. And which we're gonna see that what is the theoretical part of the SD access technologies. Okay. Little bit we are gonna study about the SDN also. We're gonna cover the QoS concept, that is my quality of service. Why do we need quality of service? Can anyone tell me? QoS. Why do we need it?
To prioritize critic traffic.
Yes. It identifies traffic and it filters the traffic on the basis of, suppose I have voice traffic, I have video traffic. Okay. I want to give priority to my video network, video traffic. So it will, how I'm going to do that? I'm going to do that with the help of QoS. Basically, we do nothing. We just change some fields. Okay. Then we have the virtualization concept. Okay. So all these practicals now, where we are going to do all these practicals, we are going to do all these practicals on our EVNG. Okay. So our machine will be look like this. Okay. This will be our virtual machine. Are you guys aware about VMware?
Yes.
Are you guys? Okay.
Yes.
Okay. So if you guys
Open
don't,
cloud.
yes, if you guys don't have the virtual machine, okay, I'm gonna provide you everything. I'm gonna provide you EVNG virtual machine, okay, license license of this VMware, and the IOL images of the Cisco devices. Okay, let me show you the how where we are gonna do all these practicals. Okay, I'm gonna demonstrate this part also at the starting of the lecture, that how you can install everything. Okay, that part we are not doing right now. Okay, so it is booting up. Till then, let us complete that what are the topics we are going to cover. Okay, so we're going to do the theoretical part of the cloud and virtualization. We're going to see what is the role of the cloud and what is the role of the virtualization. One virtualization method we are using here, where? Here. Okay. Then we are doing what? VRF concept. Okay, that comes under the data path virtualization. Okay, this part is very much important. Okay, if you go into the senior level. Okay, then we are gonna see the network virtualization concept. Okay, in the network virtualization we are gonna just go with the overview. Okay, that will not be a practical implementation. Okay, that will be just be a overview. Here I'm gonna cover the LISP and my VXLAN concept. Got it? And if there and we are gonna cover the GRE, IPsec. Okay, these both come under what? VPN part. Okay, we're gonna do all both of these protocols on my Cisco routers. Okay, if I'm gonna left with some part, okay, I'm gonna cover that part also. Right now I'm able to recall these things only. So let me just show you that how we're gonna access this thing. 192.168.131. So these are the things. Okay, these are the labs we have for our routing, switching, any devices. Right now we are going to cover the ENCOR, so that will come under the routing and the switching part. Okay, so from here we are going to create new labs. Okay, we are going to add the devices, whatever configuration we want to do. Okay, so that's it for today, guys. Bye bye. I hope I will see you soon, guys. Anyone wants to ask some questions regarding today's session?
Yes.
Yes,
Hi.
tell me.
This side, Mohammed Shafi.
Yes, hi Mohammed.
Hi. The topic whichever you have discussed is like from the old syllabus of like CCNA and CCNP. Means it will be like a refresher plus the new topic will be going to taught. Am I right? You are going to teach the new topic also?
Yes. Every
syllabus.
topics will get cleared. Okay, right now that first thing we are going to cover the switching. Okay, then we are going to cover the routing part. Okay, and after that I have told you we're going to cover the SD-WAN. Look, the proper implementation part will not be there. Okay, that is not part of the ENCOR part. For that we have complete different thing. That is my CCNP SD-WAN. Okay, for that they have a separate name.
So means there will be a theoretical part of ENCOR.
Yes, that will be a theoretical part. Okay, in which you will understand the concepts. Okay, you will not practically implement those things. Okay, but you will understand the concepts. Okay,
because when I log into the Cisco portal and if I see the syllabus, that is something different. What you have explained now.
Okay, what's the difference between that syllabus?
There are some different modules of like wireless, SD-WAN, SDX.
I have told you now, wireless we are gonna cover. WLAN I have told you. On that wireless part, they will also, you have seen that they will tell you that that's a describe part. Okay, there also we are gonna cover the concepts. Okay, what I have just told you now, the OSPF, BGP, EIGRP, the switching part, those are the implementation part.
Correct.
Okay, that's the core part of the ENCOR. Okay, the part that I haven't, basically I have told you around 3 to 4 parts only. Okay, that we are going to cover only the conceptual part. Okay, if we left with any part, suppose we are remaining with 2 topics. Okay, that where I have to describe something, okay, that we are going to cover in the 10 to 15 minutes, okay, that will not be an issue. But you have to focus on where? You have to focus on the switching part and the routing part. That's the core part of the ENCORE. Okay. If you'll get the concepts of the SD-WAN, okay, that will be a next thing. Okay. But your core is what? Your core is what? Switching and the routing part. If you'll not focus on the switching and the routing part, that how you're gonna implement the things.
Then
Okay.
what will we cover in NRC?
Look, NRC part is different.
Okay.
Okay. So basically,
Much
some of the
advanced.
look, I'm covering some of the parts of the NRC also in the ENCORE syllabus. Okay. If you'll go through the NRC syllabus, okay, basically what I usually do, I combine ENCORE and NRC. Okay. But right now we are doing what? Only the ENCORE part. Okay. But I know these some on the from the NRC, this part is also important. Okay. So I will cover that part also. That will hardly for example, from the EHRP, I'm covering some part of the NRC also. So that will hardly take 20 to 25 minutes. So I can cover that part also. Okay. That will not be an issue from my side. Okay. Although you will get the knowledge.
And what will be the duration for this ENCORE?
Look, if we that depends on the either we are starting with the weekday or weekend. Okay. If we are starting with the weekday, okay, then it will take around we can say 40 sessions, 40 to 45 sessions. Okay. 5 to 10 sessions can go up, 5 sessions can come down. Okay. It will be around 40 sessions, 45 sessions, sometimes 46, 48. Okay. If we are doing it weekend, okay, then it depends here that we are doing 3-hour class or how much hour class. Okay.
Might be you have some plan, no? Like if it is a weekend,
yes,
it will be 2 hours.
Yes. Basically, right now I am I have so many batches right now. Okay. I cover the security part also. Okay. This is my core domain where I cover different types of firewalls. Okay. So I have so many batches. I have to see the schedule. That part will depend on the management. Okay. But I will give you just a brief idea. Like if we are doing the 2-hour sessions, okay, then that will take around we can say 9 to 11 weekends. Okay. But if we are doing the 3-hour sessions, then that will take around 8 to 10 sessions, or we can say 10 to 12 sessions here. Not 10 to 12 sessions, 10 to 12 weekends. Okay. In the weekend we have 2 classes.
2 weeks.
Okay. Yes. And if we are doing the 3-hour sessions, then it will take around 8 to 10. Got it? Okay. Any other thing?
Nothing. Cool. Thank you.
Okay. So bye bye guys.
Sir, I have sir.
Yes.
Sir, excuse me. I have a little question. What do you suggest for a low-end laptop? I don't know. I want to install.
Look.
VNG.
Yes.
In cloud or something.
Yes. Let me tell you. If you have the i5, okay, and minimum 8 to 12 GB RAM, then you can complete the routing part and the switching part. Okay, without any problem.
Okay.
If you are going with for the firewall, then minimum 16 GB you need. Okay, but firewall is not in our syllabus right now, so you can go with the i5 8 to 12 GB RAM. Okay, that will not be an issue.
Okay.
Okay, in the 8 GB also it will work properly. Okay, it's just that you cannot create too much complex topologies. Okay, sometimes you will face problems. Okay, your screen got freeze. That problem will face if you make the bigger topologies. Okay, if you make the simple topologies like we are doing on the classes, if you are focusing on the concepts, then you can easily perform the practicals if you have the i5. Okay, basically the minimum requirement to install the Eve engine is i5. Okay, if you will check the documentation of the Eve.
Okay.
Okay.
Well, I have A5 CPU and 8 GB. I think it's enough for the moment.
Yes. You have i5 now. You have i5 now. Okay. And in the if you will talk about the AMD, then 5000 series will be enough. Okay. I only know about only these two processors, Intel and the AMD, right now. Okay.
Okay. Thank you, sir.
Okay.
We can build our lab on GNS also, no? It's not compulsory for EV.
Look, in the GNS, you will not perform the switching part. Okay, that's why I don't use EVNG. Okay, sorry, that's why I don't use GNS. Okay, I find it a little bit old. Okay, it's a personal choice. You can perform the practicals on the GNS also. Okay, but it's depend on the person to person. Okay, and the trainer to trainer. I use the EVNG only. Okay, because on the EVNG I can perform any types of labs. Okay, if you're comfortable with the GNS, you can go with the GNS.
The required images will be going to provide by you
for the GNS.
For the EV and GNS.
Yes, for the EVNG I will provide you. For the if you look, I will still recommend you to go with the EVNG. Okay, because in the GNS there are some glitches on the practicals. Okay, that's why I don't recommend anyone to go with the GNS. Okay, if you are a beginner. Okay, if you are advanced, you know that I will not be able to perform the practical of switching. I know this type of error will come on the GNS. Okay, then why waste your time on the GNS? If you have EVNG, if you have a proper platform like this, then use that platform. Okay, I'm gonna provide you everything for the EVNG, every images. If you need for the GNS also, I can give you that also. Okay, but I will not recommend you to go for the GNS.
Fine. Thank you.
Okay, guys. Bye-bye. Good night. Take care, guys.
Thank you. Good night.
Okay. Bye-bye. Thank you.
Thank you.